morning, my dear students. Yesterday we have seen the theorem. In continuation of that, I am going to prove this. Okay. Last class we have defined A naught equal to A intersection A naught equal to A intersection AB, A comma B. B naught equal to B intersection A comma B. These two sets are non-empty. A, why? Because A belongs to A naught, B belongs to B naught, and their intersection is empty, and A naught intersection B naught is empty. Therefore, and we are going to prove this interval A comma B cannot be written as A naught. If it is so, then this will become disconnected. If it is not so, this will become connected. Therefore, there is no separation. I am going to prove there is no separation for A comma B. So, interval is contained in Y. Y is a convex set. Convex set is connected. Therefore, the linear continuum L is connected. So, in that way. Suppose I am going to prove this is not equal. I am going to prove there is an extra element here. That is C equal to supremum of A naught belongs to this, and C does not belong to A naught, and C does not belong to B naught. So, neither A naught nor B naught. Okay, first case. Suppose C belongs to A naught. Contradiction la prove panna porom. C belongs to A naught, what will happen? Then C not equal to B, because A naught intersection B naught equal to empty set. So, either C equal to A or A less than C less than B. A less than C. But A naught is open. Therefore, every point is an interior point. C is an interior point. Therefore, there is a neighborhood which is only contained in that set. Neighborhood is an open set. There is an open interval lying in A naught. Upon there is an open interval C comma E, which completely lies in A naught. By linear continuum, there exists a point C less than Z less than E. Therefore, there is a middle point between C and E. But therefore, the whole interval is in A naught. Therefore, this belongs to A naught. But C is the supremum of A naught, least upper bound. அப்போ அதோட பெரிய எலிமெண்ட் A நாட்டுக்குள்ள வருது, which is a contradiction. Therefore, C cannot belongs to A naught. In similar way, if C belongs to B naught, then C not equal to A, because if it is equal to A, then A belongs to A, C belongs to A naught. No? So, C belongs to A naught, C belongs to B naught, intersection of contradiction. They have empty intersection. A naught intersection B naught equal to 5. Correct? Appo, either C equal to B or A less than C, adhe argument. B naught is open. Therefore, this point C becomes an interior point. Therefore, there exists a open interval D comma C, which is only contained in B naught. Since L is a linear continuum, there is a point Z between D and C. Z belongs to B naught. But Z is less than C, C is supremum of A naught. Adhanala Z enga irukum? A naught la irukum. Z A naught liyum irukku, Z B naught liyum irukuna, Z becomes A naught belongs to Z, A naught intersection B naught. But A naught intersection B naught equal to 5, which is a contradiction. Therefore, C does not belong to B naught. So, C does not belong to A naught, C does not belong to B naught, neither belong to A naught nor belong to B naught, but it belongs to A comma B. Therefore, it is not equal to union of. So, you cannot express the A comma B as a union of what? Disjoint open sets, disjoint non-empty open sets. There is no separation for this A comma B. There is no separation for Y. There is